So next one, why is the color of the sky is blue? That's the next part. This we are studying under the concept called as scattering of light. So see now, the fine particles in the atmosphere. Just now we have studied, right? The fine particles which is very thin in size, the thin in diameter or small in diameter. The fine particles in the atmosphere have the size smaller than the wavelength of the visible light. The size of these particles is what? Very small, and that is also smaller than the wavelength of a visible light. Because of that one, they can scatter the blue light when which has a shorter wavelength. Blue light has shorter wavelength than the red light. Red light will have the bigger wavelength, because since it has got bigger wavelength, which has a longer wavelength, we can say that because of this reason, where red light has got longer wavelength or bigger wavelength, because of that particular reason, we see the red light everywhere. It is seen on the ambulances, it is seen on the police vehicles, it is seen on the on the any of the telecom towers. It is seen wherever it is required, like which has to be kept as a indication for alert. There we see the red lights. Well, even if it is at the far distance, we can see that red light very easily. What is the reason behind that one? The red light has got the very longer wavelength. And which color has got lesser wavelength? That's a blue light. Blue light has got the shorter wavelength, and the red light has got the longer wavelength. Since the particles, the white light which passes through the finest particles in the atmosphere, your atmosphere or the sky looks as a blue color. So see now, when the sunlight passes through the atmosphere, the fine particles in the atmosphere scatter. These fine particles, which are smaller in size, they scatter, and because of the scattering of the fine particles, the blue color more stronger than the red. So that's why the sky appears to be blue in color. So whenever the light passes through the atmosphere, mostly if it is passing through the finest particles, which are very smaller in size, because of that one, the scattering of particles takes place, and the light passes through the scattered particles, and that's how we get the scattering of a blue color, and it appears as it makes us to appear as a the sky to appear as a blue in color. So this is a reason behind why does the sky appears as blue color. Now see the other second part. We are going to study about first picture is done. We are going to study of the second picture now here. If the earth has no atmosphere, there would not be any scattering of light. If the earth is having no atmosphere, means what? Atmosphere means what? It's an air. We have studied different kinds of atmospheric layers, ionosphere, stratosphere, and different kinds of layers of atmosphere, right? If earth does not has got that particular air inside that one, if the earth has no atmosphere, there would not be any kind of scattering of light, and then the sky would appear as a dark color. Sky would have been appeared as a dark color. The sky appears dark at very high altitudes. When the sky will appear as a dark whenever we go up in the altitude. Means what? When we go up in the altitude, means what? If you go up from the Earth's surface, the atmosphere levels also will go down. If the atmosphere is not there in that altitude, at that particular height, ultimately the sky looks like a dark in color. So this is called as a scattering of light. And how does the sky appears to be blue, and why does the sky appears to be dark if there is no atmosphere? So this is what we are studying over here. Just now, whatever I explained is this part. White light from the sun is composed of all the colors of the rainbow. We know that the white light which is coming from the sun, it looks like a rainbow. Why? Because of the scattering of the light. Then more than 20 miles above the earth, the sky is black. Just now I told, right, as we move up from the, if this is the earth, if you move up from the earth nearly 20 miles, then the sky becomes completely dark in color, black in color. Around 18 miles up, the light encounters the air molecules, and that scatter the blue light until it's coming from all parts of the sky. So until, see now, if this is the Earth's surface, if you go to the height of 20 miles, here you see the sky appears as a completely black color. But at the verge of 18 miles from Earth to 18 miles in the upward, here at the 18 miles, the light will encounter the atmosphere of the Earth, and because of that atmosphere of the Earth, the sky looks like a blue in color. So beyond this 18 miles, your sky looks like dark in color only. So this is what we call it as an this is about how the sky looks as blue in color. What is the distance? The sky looks as blue in color from Earth to 18 miles in the upward direction. Means in the upward direction. Whenever it reaches to 20 miles from Earth, the sky completely looks like a dark in color. That's black color. Why? Because they're at 20 miles, slowly from 18 to 20, slowly what happens? The atmosphere goes on reducing. Once the atmosphere goes on reducing, it will be completely pitch dark. So next one, the color of sky at sunrise and sunset. So see now, what happens? The color of sky at sunrise and sunset. Let us see now. At sunrise and sunset, the sun here. At the sunrise and sunset, the sun is nearer to the horizon, and the light from this sun travels through the thicker layers of the atmosphere. Whenever the sun, if this is called sunrise and sunset, if let me say, let me where to take it as sunrise and sunset. Let me call this one as a sunrise, and let me call this one as a sunset. Okay, this part is sunset. See, you know, if light is traveling through this part here at this horizon, the atmosphere will be having, at the sunrise part, the atmosphere will be having the thicker layers. Even at the sunset, the atmosphere will be having a thicker layers. So see now, at the sunrise and sunset, the sun is nearer to the horizon, and the light from the sun travels through the thicker layers of the atmosphere, and longer the distance through the atmosphere. Here, the layers during the sunrise and sunset will be thicker in nature, and also the distance of the sun from the Earth atmosphere will be more, and here also at the sunset also it will be more. Nearer the horizon, most of the blue light and shorter the wavelength will be there. Whenever the sun is nearer to the horizon, if the sun is far over the horizon, you will be having about the thicker one. So near the horizon, most the blue light and short wavelengths are scattered away by the particles of the air. At the horizon, what's happening? Most of the blue lights and the short wavelengths have been scattered away from the particles. And red light and longer wavelengths reaches our eyes. What happens here? At the origin, what happens? At the origin, the blue lights have been scattered because of the thick, what I told, whenever the light ray passes through a thin layers only, thin particles only, blue light is visible. But at the origin, what's happening? At the origin, the layer will be very thick and the particles also will be bigger. Because of that one, the blue light is not visible at the sunrise and sunset. And since at the sunrise and sunset, the layer is thicker, atmospheric layer is thicker, and the particles are bigger or larger in size, the red color, the more wavelength colors are visible, that is the red color will be visible. That's why most of the time during the sunrise and at the sunset, your atmosphere, the sky looks like red in color. So that's why the sun appears as reddish. Because of that reason, the sun appears as reddish at the sunrise and sunset. I hope it's clear to you regarding why the color of the sky at sunrise and sunset. So now here, we have completed a concept about this human eye in the part 1, and again we have completed about refraction,